The different matrix operations can be combined in a problem. Check out some operations in a single problem here in Numerical Solutions to see problems. Given three 2x2 matrices, we are tasked to verify the four operations. A is to check the associative property of multiplying matrices, verified by matrix A multiplied by matrix BC, and this should be equal to matrix AB times matrix C. The second requirement is to have matrix A multiplied by the sum of matrices B and C, and this should be equal when we distribute matrix A to both matrices B and C. The third twist is similar with the second, though the operation is subtraction. The last task is to have matrix ABC multiplied by a scalar, and this should have equal result when matrix 3B is multiplied by matrix A, then matrix C. Let's start with the first task of taking matrix ABC. The first operation would work with matrix BC first, and that would give matrix B multiplied by matrix C. To discuss this clearly, the intersection method is used, although you can multiply matrices by row times column strategy. Start by multiplying the first row of matrix B times the first column of matrix C. That would give 1 times 1 plus -1 times -1, which is 2. Continue with the second row of matrix B to get -2 times 1 plus 2 times -1, giving -4. The next intersection is back to the first row of matrix B times the second column of matrix C. That gives 1 times 4 plus -1 times -3, which equals to 7. And complete matrix BC by intersecting row 2 with column 2, which gives -2 times 4 plus 2 times -3, giving -14. So matrix BC is computed with elements 2, 7, -4, and -14. Matrix A is then multiplied by matrix BC. We do that by taking first row times first column. That is 1 times 2 plus 3 times -4, which is -10. The next is from row 2 with column 1 to have 5 times 2 plus 2 times -4, giving 2. Moving back to row 1 with column 2, we multiply elements and have 1 times 7 plus 3 times -14, which is -35. Lastly, row 2 with column 2, that is 5 times 7 plus 2 times -14, which results to 7. Now we got matrix A with matrix BC having elements of -10, -35, 2, and 7. Let's verify that the same elements come out when we take the product of matrices ABC a little differently. This time, start with matrices A and B. So first row and column give 1 times 1 plus 3 times -2, or -5. Row 2 times column 1 has 5 times 1 plus 2 times -2, giving 1. Next is row 1 with column 2, which has 1 times -1 plus 3 times 2, or 5. Then the last element is computed as 5 times -1 plus 2 times 2, or -1. That is from row 2 times column 2. Matrix AB thus has the elements -5, 5, 1, and -1. Matrix AB is then multiplied by matrix C, where row 1 column 1 has -5 times 1 plus 5 times -1, that is -10. Row 2 with column 1 is solved as 1 times 1 plus negative 1 times negative 1, giving 2. Then back to row 1, then multiply column 2 to have negative 5 times 4 plus 5 times negative 3, which yields negative 35. Then last is row 2 multiplied by column 2. That has 1 times 4 plus negative 1 times negative 3, or 7. So matrix ABC has the elements negative 10, negative 35, 2, and 7. The same elements from the previous procedure. So matrix A multiplied by matrix BC is verified as giving same results when matrix AB is multiplied by matrix C. Task B is multiplication with addition of matrices. Verify that matrix A multiplied by matrix B plus C is equal to matrix A times B plus matrix A times C together. Given the numerical elements, let's start by adding matrix B and C, and the operation requires to add only those elements with the same index. So elements 1s should go together, that is 1 plus 1, which is 2. Elements 1, 2 together as negative 1 plus 4, which is 3. Then elements 2, 1 are added, which gives negative 2 plus negative 1, that is negative 3. And elements 2, 2 are added like 2 plus negative 3, resulting to negative 1. So matrix B plus C has the elements 2, 3, negative 3, and negative 1. Now is to multiply matrix A with the matrix we just solved. Row 1 and column 1 has 1 times 2 plus 3 times negative 3, which is negative 7. Row 2 times column 1 has 5 times 2 plus 2 times negative 3, giving 4. Then row 1 again, but with column 2, which gives 1 times 3 plus 3 times negative 1, or 0. Then row 2 with column 2, that is 5 times 3 plus 2 times negative 1, resulting to 13. So matrix A multiplied by matrix B plus C has elements negative 7, 0, 4, and 13. Let's jump to the other procedure to compare the matrix we just completed. First is to have matrix AB by multiplying matrix A with B. That would be completed starting with row 1 column 1 of 1 times 1 plus 3 times negative 2, which is negative 5. Row 2 times column 1 provides 5 times 1 plus 2 times negative 2, or 1. Then row 1 again with column 2 has 1 times negative 1 plus 3 times 2, giving 5. Then row 2 with column 2 completes the matrix by multiplying 5 times negative 1 and adding 2 by 2, or that is negative 1. So the matrix of AB has the elements negative 5, 5, 1, and negative 1. Also take matrix AC with the same procedure as done earlier. Row 1 with column 1 has the element computed from 1 times 1 plus 3 times negative 1, which is negative 2. Row 2 with column 1 has 5 times 1 plus 2 times negative 1, giving 3. Then back to row 1 with column 2 this time, yields negative 5 as we multiply 1 and 4, then add 3 and negative 3. And last again is row 2 with column 2 that has 5 times 4 plus 2 times negative 3, giving 14. So matrix AC contains the elements negative 2, negative 5, 3, and 14. The next step is to add both matrices AB and AC. And again, elements with the same indices are added. That is elements 1, 1 together, or negative 5 plus negative 2, that is negative 7. Elements 2, 1 are 5 and negative 5 added together as 0. Next is to take the summation of elements 2, 1, which are 1 and 3, easily added to 4. Then elements 2, 2 added together becomes 13. So matrix AB plus matrix AC contains elements negative 7, 0, 4, and 13. The same elements we got from the first procedure. So task B is also verified correct. The third task includes subtraction as opposed to task B. So start with the difference of matrix A and C. So same index elements are involved but only subtracted. Elements 1, 1 are 1 minus 1 giving 0. Elements 1, 2 have 3 and 4 subtracted together to have negative 1. Elements 2, 1 then gives 5 minus negative 1, which is 6. And lastly, elements 2, 2 with 2 minus negative 3, or that is 5. So matrix A minus C has elements 0, negative 1, 6, and 5. Next is to take the product of matrix B with matrix A less C. Check for intersections for the procedure starting with row 1 and column 1 to get negative 6 from 1 times 0 plus negative 1 times 6. Row 2 with column 1 has negative 2 times 0 plus 2 times 2, and that is 12. Row 1 again with column 2 gives negative 6. When we multiply 1 and negative 1, then add negative 1 times 5. Then complete the elements by solving row 2 with column 2. That is negative 2 times negative 1 plus 2 times 5 giving 12. So matrix B times matrix A minus C has the elements negative 6, another negative 6, 12, and yet another 12. For the right side of the comparison, we start with matrix BA, that is done through multiplication again. Thus row 1 times column 1 has 1 times 1 plus negative 1 times 5, and that is negative 4. Row 2 with column 1 has negative 2 times 1 plus 2 times 5, or that is 8. Next is row 1 with column 2, giving 1 times 3 plus negative 1 times 2, that is 1. Then row 2 with column 2 has negative 2 times 3 plus 2 times 2, or that is negative 2. So matrix BA has the elements negative 4, 1, 8, and negative 2. Proceed to determine the elements for matrix BC through multiplication again. So row 1 with column 1 has 1 times 1 plus negative 1 times negative 1 giving 2. Row 2 with column 1 has negative 2 with 1 plus 2 times negative 1, and that gives negative 4. The next column can then be completed starting by multiplying row 1. That is 1 times 4 plus negative 1 with negative 3, or that is 7. Then row 2 with column 2 gives negative 2 times 4 plus 2 times negative 3, resulting to negative 14. So matrix BC has the elements 2, 7, negative 4, and negative 14. Now subtract matrices BA and BC. Elements 1, 1 show negative 4 minus 2 giving negative 6. Elements 1, 2 have 1 minus 7 or negative 6. Then elements 2, 1 are 8 and negative 4 subtracted together to give 12. And elements 2, 2 have negative 2 minus negative 14 giving 12. So matrix BA minus matrix BC has the elements negative 6, negative 6, 12, and another 12. The same values of elements solved earlier. So the third task is verified correct too. The last requirement for verification is including a scalar into the matrix. We work with 3 times matrix ABC and check if this yields the same elements when 3 is multiplied to matrix B first before multiplying the rest of the matrices. First is to take 3 times matrix ABC, where this matrix has already been solved in the first requirement earlier. So let us just take the elements from there. Start from 1, 1 with 3 times negative 10, giving negative 30. For element 1, 2, we get 3 times negative 35 or negative 105. Then element 2, 1 has thrice of 2, which is equal to 6. Element 2, 2 has 3 times 7 or 21. So matrix 3 of ABC has the elements negative 30, negative 105, 6, and 21. Let's compare the matrix elements with the other procedure where we start with 3 times matrix B. With that, we get 3 times 1 or just 3 for element 1, 1. Element 1, 2 is 3 times negative 1, which is negative 3. One row down, we have elements 2, 1 to give negative 6 from tries of negative 2. Then last is 3 times 2, which is 6 for element 2, 2. So matrix 3B has elements 3, negative 6, and 6. Multiplying matrix A to matrix 3B is started from row 1 times column 1. That is 1 times 3 plus 3 times negative 6, giving negative 15. Row 2 with column 1 has 5 times 3 plus 2 times negative 6, yielding 3. Row 1 again with column 2 has 1 times negative 3 plus 3 times 6, or 15. Then row 2 times column 2 has 5 times negative 3 plus 2 times 6 as equal to negative 3. So matrix A3B has the elements negative 15, 15, 3, and negative 3. Next is to multiply matrix A3B with matrix C. Start with row 1 times column 1. Negative 15 times 1 plus 15 times negative 1, which gives negative 30. Row 2 with column 1 contains 3 times 1 plus negative 3 times negative 1, or 6. Then row 1 with column 2 has negative 15 times 4 plus 15 times negative 3, giving negative 105. And lastly, row 2 with column 2 shows 3 times 4 plus negative 3 times negative 3, and that is 21. So matrix A with 3B and C has the elements negative 30, negative 105, 6, and 21. Again, the same elements from the solved left side of the verification statement, so the relationship is verified correct.